How I came about putting up this talk was I've been working for a startup called Unbxd. So we've been building search and navigation for e-commerce websites. So I've been working on this for the last year and a half, and which is why I picked a topic like this. So what I want to cover in this talk would be like basics of how query parsing would work, go on to how your similarities would rank documents, and then move on to adding signals and other data so that your ranking would improve. Uh, so that would be my the agenda for the talk. And even if you're not satisfied, then you could customize search on a per query basis. So all of this, how to use Solr to use all of these would be like my talk. So let's go on to the first slide where it's basically how do queries get, how do we score documents, right? So to understand that, I'm going to be talking about a little bit about query parsing. So suppose we have a document, a simple phone document, product, which is basically the new Nexus 5. So it says LG Nexus 5, brand being LG, category it comes under smartphones, and you could have various tags like phones, touch phones, smartphones, Android phones, stuff like that. So typically this could be one product in an e-commerce website. So now someone comes in and searches for LG Nexus. Okay. uh, how would you go about forming a query, and how would this work? So, firstly, in Lucene and obviously in Solr, scoring and querying is field relative. So basically, all your scores are computed on a field. Your statistics, your TF, IDF, all your statistics are on a per field basis. Uh, so suppose you want a query which matches against all the fields, right? So approach one, you would use like a boolean query. So you would make like term queries which would have fields as title and values as each token of your search query. So you would have a few term queries out there, and you would put all of them in a boolean query, and that's how you would form a query. So what would happen in this case is, uh, all these various term queries formed inside the boolean query, if it matches or any of them, the scores would get added. So what happens in this case would be the score would be the sum of query 1 through query 4. Now, like you can see, query 1 and query 3 both are for the token LG on different fields. So if you used a boolean query approach, what would happen would be, if it matched both fields like it would in this document, the scores would get added. So this might not be the ideal way to go about it. So you could use the disjunction max query. So what a disjunction max query would do, it'll have subqueries, and within these subqueries, it would take the score from the maximum subquery. So essentially, how you would form a disjunction max query would be, you would take a single token and make these queries and put it in a disjunction max query. So you would have these disjuncts. So one disjunct would be a term query which would have title to LG, the brand to LG, and you would put them in a disjunction max query. Same thing for the nexus. So you would have these two disjunction max queries, and what this would do is it will take the score. So if LG matched both your title and your brand, it'll take the score from the most, which should be the highest score. So that's how disjunction max query works. Now in Solr, if we use dismax or edismax, this would be the default way in which your query would get formed. So that's just about getting an idea of how query parsing works. Moving on, I'll just give talk shortly about the default similarity. So your default similarity is your TF-IDF based similarity. where TF would be the number of occurrences of the term in the document, IDF being it will be a measure of how unique or rare the term is, and then you would have other factors like normalizations. So you would have field normalizations and query normalizations. You would also have this coordination factor, which is built into the default similarity. So what this tries to do is it'll give it like an and factor to the query. So the number of matches to the number of total terms in a query, it'll like give you ratio and it'll multiply it by that ratio, so thereby giving it another factor to the scoring. And again, these statistics are on a per field basis. So I'm just going to talk about how this default similarity might not work for your ranking formula or your data set. Uh, let's take term frequency as a start, okay? So you might have two products. One might be an iPad Air, and the second might be an Air case. But the title would go like iPad Air case works well with an iPad 2 and an iPad 3. So what happened is in both these documents, the term frequencies are skewed. So iPad term frequency for document 1 would be 1, while the term frequency for iPad in product 2 would be 3 in this case. So if your query were to be iPad and if uh, TF was the factor here, product 2 would get listed before product 1. But hey, when you search for iPad, everyone wanted the iPad before the cover, right? So one way to do this would be you could like just implement a new similarity class and make term frequency 1. So another reason why you could do something like this would be so suppose you have people your merchant center where people upload products. So they might put in they might stuff keywords in there to like to make sure that the documents rank higher. So doing something like this would essentially make it a level playing field out there. So this is one approach where you could modify the term frequency statistic in the ranking algorithm. Secondly, I'll talk about inverse document frequency. So what happens in inverse documents frequency is if you have two products, say a brown jacket and a leather jacket. Now, if your query were to be brown leather jackets, so what happens is the query matches both products and it matches two tokens in both the products, and one of them happens to be jacket. So IDF is not a measure of usefulness, but it's a measure of rarity. So in this case, should IDF be the true judge in deciding whether brown is more important than leather, right? So if if we let IDF do it, it probably depends on your data set, right? So you might depending on how many brown jackets you stock versus how many leather jackets you stock, the ranking of these documents would vary, right? So what we thought is your document set is probably too little to guess whether brown would be more important than leather in this case. So a approach which one could take is you could have this vast major data set which would be similar to what your vertical in e-commerce is, or you could take if you're working on suppose a career building site, you could have more data from other sites, and that way what would happen is the IDF would be more smooth, like it could be a better judge because if you have a data set which is big enough, there is a good chance that it is a uh, true measure of how useful the document would be. So we tried this out and it worked out well. Essentially, so again we used the custom similarity class and we overrid the IDF to use this. Then, so now when you have two documents which have two token matches the same, essentially the normalizations will take care of what comes up like ahead. So this, I would call it like the tie factor here. So basically, these were the modifications we made to the TF-IDF scoring model to take care of our data set. Now I'm going to talk about function queries and how to add various signals into your scoring algorithm. So essentially what a function query is, it allows you to use actual values of a field to compute functions and use them in your relevancy score, right? So function query would iterate over all the documents serially applying the function. And also, you can multiply the function query score computed in as a boost parameter in your extended dismax query parser. So you could use edismax and you could use a function query, and the functions query, the score computed could become a factor, and you could easily plug that into your scoring model. So let's include popularity data as a start. So popularity for you could be anything: maximum selling items, highest viewed products, trending, uh, or you could probably use all these fields to combine them into one. You would compute this popularity score offline for each document in your index. Then what you would do is you could re-index this document with the popularity store. Uh, so if your data set is small, you don't mind re-indexing it over and over again. But suppose you had a data set which was big enough, you could very well use an external file field or a parallel reader based approach. Now the function query would essentially be something like you would put this as your query parameter. This assumes that you're using extended dismax query parser. You'd use boost equal to the field which contains the popularity value into your score. So this would compute the score for you. Now, coming in Lucene 4.6 is a expressions module which makes it really simple to rank documents. So you could do something like this in Lucene as of now. If you build trunk, uh, you could do underscore score plus log of popularity, and you could use any field in your index and use this JavaScript expression to compute the score. Now this is like a really easy and efficient way to score ranked documents. That would be the expressions module. So we've included popularity data. Now I want to add click-through data into my index. So click-through data, you have your query and you have the list of documents that a user has clicked, and you rank give them weights accordingly. So if he's clicked on a document which comes on the second page, you want to give it a higher boost so that it comes to the first page for other users going forward and stuff like that. So you could I'm not going to get into the details of how to compute this score, but essentially once you have this click through data with the scores computed, you could use function queries again to to use that into your ranking algorithm. So how I would say adding click through data would be good would be to use it on a per query or a bunch of queries. So you could have these set of queries and you want to apply this click through data to it. You have this relation made up in your external application. Once you have this data, you would use a function query. So like I said, you would have these IDs and the associated boosts with it. Now this would be applicable to a query or a set of queries. On this, uh, what you would do is you would use the function query which would take all these values. And so essentially, like I said, a function query would serially go through each document. Now you have this data into your function query, and if you get a match on the id, you would boost it. So that's how you would implement the function query in this case. Now so with that done, click you could add click through data. Now we've added popularity, click through. Probably you want to boost documents which are coming in more recently. So so either you could blindly sort the result by uh, like newest to oldest sort of a way. Now, or you could give it a slightly higher boost or a more preference to newer products in your data set. So how you would do this is you would use this function query, which basically takes milliseconds between today and the published date. uh, you take this and you apply the recip function query. What recip is, it basically takes parameters m, x, a, and b. So your formula would be a by mx plus b. Now this example straight off the wiki. So this would work and it'll boost documents which are more recent. Now suppose you want to play around with these values. So I want to pick A as 2, B as 1, and obviously I want to keep M as the same, which is the number of milliseconds in the year. Now, if I change A and B, you could have different boosts associated with each product. So it depends on the curve you want or the boost factors you want the documents to be, and the average decay period of your product. You could change these parameters to give it a good function query and a good boost to it. So in this case, if I chose A as 2, B as 1, it gives a boost 2 for a product which was uploaded, say, today. It would give a boost 1.3 for a product which is half year old, and it'll give a boost of 1 to a document which is a year old. So again, if we play around with A and B, we can get various boost factors, and you could customize this to your data set and your uh, basically the way the products are in your data set. Now I'm going to go on to say a lot of e-commerce websites have this particular notion of what should come up for a query, or they want to be able to customize this behavior. So in Solr, there is this query elevation component. What a query elevation component would do is you would take your top n queries and you would give it to the query elevation component. Now, what a query elevation component would do is you can fix documents for certain queries, like I said. For this, no scoring is taken into consideration for these documents, for these queries. So this is how you would configure your elevate.xml file, or the file where you would say the configuration for particular queries, what sort of products you want to come right on top, or you want to exclude them. So query elevation component has this good feature where you can say you want to boost like a product which the id of it you would of it would, like of a nexus, suppose, and you could also go like I want to exclude certain products from the query search result. So you could use that with the exclude true parameter. This is how you would customize what do you say, experience on a per query basis. So this is what I have for the talk. Basically, so like I said, we spoke about basics of query parsing, the TF, IDF, and how you can modify it for your data set. We included function queries and various signals into our ranking algorithm. So yeah, this is what we've been doing, and it's been working out pretty nice. And Solr gives us the extensibility to add various function queries, extend components and stuff like that, which makes all of these possible. So, any questions about the scoring model, or like have you tried experimenting with other models and stuff like that? Okay, so the question is the query elevation component, does it give you a dashboard or something like that over configuring XMLs? The answer would be no, but probably you could like open a Jira out there, and the Solar admin panel would be a good place where you could do stuff like this. So yeah, someone could go ahead and open up a Jira for this, I'm guessing. So you're saying you have these products, right? And how would you make sure the iPad would come before the iPad cases? Yeah. So if the query would be iPad case, definitely, since more tokens match product 2 in this example, the iPad case would come over the iPad. But suppose you're saying the query is iPad, right? Is that correct? Okay. So the question here is, so in his case, merchants upload data on their platform, and like one merchant might have a particular way of formatting the data, so he would put iPad in a title. The other person might not put it, or put it somewhere else. In which case, the question is, how do you handle such cases, right? Okay, I would say it depends. So you could probably, one approach would be to, like, if you're not sure, like, at all on where he's putting the data, you could probably have a copy field, which would be a summation of all your fields in your merchant center, suppose. So it would be a sum all of all your fields, and you could use ranking, or you could match against that field. Otherwise, another approach, what I can think of is, suppose you understand what you're wanting to sell. So if you're promoting, suppose iPad covers, or if you're an accessory store and you have more margins on that and you want to sell that, so you could use again function queries where you have this data in you, like you would have the price field in your document, right? So you could give boosts to documents which are like of a price which is lesser price. So that way you could get, suppose, cases over the actual iPad. So you could control this using the data in your index, uh, like the price in this example. Did I solve your question? I, thank you.